All right, in this problem, we're focusing on this beam. This beam here is 4 meters long, and there's a weight hanging off the end of the beam, which is 300 newtons. The beam itself has a weight of 200 newtons, which we're going to put directly in the center, because that's where the center of mass is. 200 newtons directly in the middle. And then what we're asked to find is the tension in the cable. Okay, to do that, we're going to need this angle in here. So you got to do a little bit of trig. So we got all three sides. There's a triangle right here. See that triangle? We got all three sides of the triangle. So theta is going to equal tangent inverse opposite, which is 3, over adjacent, which is 4. So we find out that this theta is equal to 36.9 degrees. Okay? All right, so I'm going to draw a nicer diagram for that beam. So if you don't mind, I'm going to erase this. Everybody got that in their head? It's a 3, 4, 5 triangle. It's on your worksheet too. It's right in front of you on your paper. Okay, so I'm going to draw a free body diagram just for the beam, showing all the forces that act on the beam. So we have the weight of the beam itself that goes directly in the middle, 200 newtons. We have a weight hanging off the end of the beam here, which is 300 newtons. We have a rope that's holding the beam up, and we call force in a rope, that's called tension. So that's tension there. This angle we just solved for is 36.9 degrees. Now, over at the left end of the beam, there has to be a vertical force. I'll call this FV for vertical. There has to be a vertical force preventing the beam from falling, because, you know, if the beam weren't attached to the wall, what would happen to the beam? It would fall, right? It'd just come right off the wall. And then there has to be a horizontal force that way. So I'll call that FH for force horizontal. But look, these two forces are not going to factor into our solution. Do you want to know why they're not going to factor into the solution? Because I'm going to stick the axis right there. Okay? If that's our axis, FV and FH would not cause a torque, because forces on the axis cause no torque. Does that make sense? So they're not going to matter anyway. All right, let me clean this up a little bit. So we'll just take those away because they're not going to matter. So this point right here is our axis. Now, clockwise, counterclockwise. Well, let's do our lengths first. In the diagram, we were told that the length of the beam was 4 meters. So let's do the distances in red. Okay, so the length of the whole beam is 4 meters. So measuring from the axis, that's 4. So what would be the distance to the middle? 2. And then that's pretty much it. Now the one tricky thing for this problem is notice that tension here is tension perpendicular to this 4. No, that's what makes this problem challenging. Right here, figuring out your distance for tension. So how do you go about doing this? Well, what I would do, extend your tension. So you know what, let me erase. I'm going to erase the problem. So we're solving for T. So we're going to go like this. We're going to extend the tension up like this. And now what we can do is we can draw a perpendicular distance to the force, right? So this line right here represents the force. That's the force. This is the perpendicular distance from the axis to the force. Because that's the definition of lever arm. When you say that torque equals force times lever arm, what's the definition of lever arm? Perpendicular distance, axis to force. And that's what this is right here. That's the perpendicular distance. So can we get it? Yep, because what's this distance right here? 4. We have that distance. So this distance here is going to be equal to sine 36.9 times 4 meters. And then that comes out as 0.6. What's that going to be? It's going to be 0.6 times 4. This is 2.4 meters. So we had to do a little bit of trig. Okay? So now, it's not too bad. So the way we're going to solve this is by summing the torques. Okay, clockwise, counterclockwise. That's the sign convention for torque. These two guys are what? Clockwise. And how do you got to know where the axis is to do that? The axis is over here. So these two forces are trying to pull the board clockwise. Tension is trying to pull the board counterclockwise. So let's say that clockwise is plus, counterclockwise is minus. Okay, so now we sum the torques. So let's do the positive torques first. So we got 300 newtons. Okay, now what was the distance for the 300? 4. Is that perpendicular? So 4 meters from the axis, perpendicular to the force, we're good. So that's 300 times 4. Now, let's go to the 200. 200 newtons. So what's the distance to the 200? 2, and that's perpendicular. Okay, and then go to tension. Minus tension. Now, what's the distance perpendicular to that force? Well, we figured it out already. It's 2.4. Okay, the sum of the torques will cancel because it's not going to rotate. And then now the only thing missing is T. So you solve for T and you get 667 newtons.